Okay, so the last one I've got for you is the Hyundai. The Hyundai is the oddest of the bunch, but it is our largest single customer, right? Hyundai is currently the largest single customer for Remy. But to me, it's kind of the oddest of the bunch because there's more than one and there shouldn't be. I don't really get that. So Hyundai AMS, alternator management system. All the same features. So soft start's built in the regulator, load response control built in the regulator, those things we talked about at the beginning. It's fail-safe mode, and I'm cautious about using the word fail-safe with Hyundai because fail-safe is also a normal operating mode for Hyundai, which is one of the things that makes their system different than everybody else's. But the AB normal mode, abnormal mode, and it's at 14.5 volts because it's a normally used mode, is where the other manufacturers were 13.8 because it was a default get-home mode. This is actually a mode we use. So the COM circuit's talking about the two command circuits just like we have with the other models. The command circuit frequency is roughly 125 and it can either be 7.5 or 12 volt depending on the application. The duty cycle represents the load just like it always has for everybody else. Here's our duty cycle chart. Same kind of numbers basically as we've seen for both other manufacturers. The FR circuit, the feedback, it is 12 volt 200 hertz or 12 volt 250 hertz. And it might be inverted in some applications. So it's the same deal. You're going to get one or the other. How it works. So key on, engine off. Now here's one of the places we find out that Hyundai's a little different. It still has a lamp circuit. It's a very traditional lamp circuit. When you turn the key on, voltage, it comes from the instrument panel module, not from the light itself like we're used to, right? Normally current goes through the bulb into the alternator. It's an LED, so it's a module that does it. But it sends voltage out like a traditional lamp circuit. Because the alternator's not started yet, we're key on, engine off. The L terminal gets grounded by the alternator. We turn the lamp on. Very traditional lamp circuit. Now if you started the car up right now with no communication, it would just go into that abnormal mode, right? Because it got an on command, it was told to work, so it would go into charging at 14.5. Okay, so now the PCM's going to send out one of the two signals out to the regulator. It's going to watch for feedback that's either going to be a small duty cycle or a large duty cycle, inverted, the two inverted versions. The numbers are over here. I won't read them to you. You won't remember them. They're in your books. Okay, so you're going to get back one of the two signals. So now the alternator's ready to go. You start it up. It lets go of the lamp circuit because now it is running and charging. The light goes out. So now the battery sensor, which is on LIN circuits, and I heard some of you guys talking about that before. You guys deal with LIN a lot? Is LIN a common circuit for a lot of you guys? Because it's certainly the up and coming for us. It absolutely is up and coming for us. The battery sensor in this system is on LIN, but only the battery sensor, which is kind of odd. The rest of it's not. So the battery sensor is monitoring the battery. It tells the PCM what's going on over the LIN network. The PCM's watching the feedback from the FR circuit, and it makes decisions about where to make it charge. Now, does it say it on this screen? Yeah. It operates it in one of two modes. So for Hyundai, and I use the two mode word cautiously, there's a charge mode and a discharge mode. But there's also this AB normal mode, but that's kind of stands as its own. So in normal operation like this, it works in one of two modes, charge mode, discharge mode. Discharge mode, let's see, oh, it failed to abnormal. We're going to go over both those modes in detail, and I'm going to try to show you one on the car if I can. So the abnormal mode is simply the PCM quit talking. That automatically sends it into that 14.5 volt state. Now it says the reasons are stop reasons and fault detected. So if it's broken, it just quits talking, but stop reasons are I turned on the windshield wipers. Right? Now for GM, that fell into a mode, right? Wiper mode. Or if you turn on the headlights, that's a stop reason. For GM, that was called headlamp mode, right? But for Hyundai, when you make any stop reason, it just throws it into this normal mode where it doesn't talk to the alternator anymore. And then this becomes simply load feedback. And for Hyundai too, you know, whether this is the, and I wish I had both of them on there, whether this is the short duty cycle or the long one, is simply the rotor triggering from the regulator. It's either whether you see when it's triggering or when it's off triggering. That's all that determines which way that signal is facing. So the two modes, charge mode, after startup, if needed, because we're going to talk about that one specifically, its operating range is somewhere in the 12.5 to 15.5 volt rate. So during deceleration or coasting, times you don't have a lot of load against the engine, it makes it charge the most. Discharge mode, when you're under heavy load or cruising, basically can almost shut it off, 12.2 to 12.7, anytime you're under load. And then of course the abnormal mode we've already talked about. So this screen, which is kind of busy, kind of talks about, and I tell you, Hyundai's not the only one doing this. Honda's doing this too. Honda is really, the Honda system is full LIN now as of 2013 or 14. And it does this same kind of stuff. This is kind of neat though. So I'm going to kind of hit what's on here first. Alternator, B+ wire goes to the power distribution box, and then it goes to the battery to charge the battery, or after vehicle loads, right? So when you start this car up, and this is easy to do, key on engine running, idle speed, battery has to be near 100% state of charge. Really needs to be right on 100% state of charge for this to happen. And actually under heavy load. These are numbers we actually took from the car. The alternator is only at 12.7 volts. The battery is only at 12.58 volts. If you're a mechanic, if you're a technician, and you walk up to the car and you stick your voltmeter on the battery and you start it up and it's at 12.5, what do you think? It's not charging. It ain't working. It is. It is though. So in this example, and these were numbers from a live car we measured, there's 84 amps coming out of this alternator at 12.7 volts. At the same time, and you see the arrow represents amperage movement. At the same time, the battery's at 12.58. There's 10 amps coming out of the battery towards the car, and those are shared, meaning total vehicle demand right now is in the, 94.7. So it's sharing the load between the battery and the alternator intentionally. Hyundai is the first car I ever saw do this. Now, again, the key to this is the battery is near 100% state of charge.
How can they do it if on one side you have less voltage than on the other side?
Well, truly, the difference in potential here, for there to be current flow this way into the battery, the difference between battery voltage and charging system voltage has to be something like, and I won't swear the number's dead on scientific, 1.5 volts difference.
Oh, really?
Before it actually forces it into the battery. If you come up just above battery, like they were at 12.5, if you bring this up to 12.9, you still won't charge the battery. And the number I've been given or heard repeated on that is about 1.5 volts difference before you really create charge back into the battery. So in this case, we're just sharing the load between the two, right? Now, all we did to this car in this application is we brought it off idle. No change to the car, just grab the throttle and add a little throttle to it. Now our voltage jumped up where we wanted it, 14.2, 14.5. Our amperage became 94 and so here, pushing out of the alternator, but now we're pushing into the battery, and that has a negative sign on it because I didn't turn that guy around, right? Any guys who use it's because graphic-wise, it's too much of a pain in the butt for me to turn that around. So I just made it a minus up there. So now we're actually charging the battery. The only difference between these two slides was we took this car off idle. Honda and Hyundai are the only ones I've seen do this so far, but we're going to see everybody do it, right? Because if you're doing this, you're not working the engine very hard at all, right? We got this guy turned down. We're not asking for a lot of amperage or a lot of horsepower from the engine to run the alternator. We're sharing it with the battery, keeping battery state of charge low. You bring it up, you do this. Now, from a technician point of view, we have been told since before I was around, when you're diagnosing a charging system, you're supposed to be somewhere between 1,500 and 2,500, depending on the car maker, always. When you hook up a VAT40, a load checker, when you do anything that's supposed to be off idle, isn't it about 1,500, Adam? When did you ever do it? Never. As a technician, and I spent my share of time in the dealerships, you just checked them at idle. It worked fine. You didn't have to bring them off idle. So it became a habit for technicians to just do charging system diagnosis at idle. Here's why that doesn't work anymore. And that's what I really have to drive home with technicians is, and this will apply to everybody as we move forward, but with Hyundai and Honda already, if you're sitting at idle, you may get tricked by this kind of an issue. You bring it off idle, you'll get out of that kind of an issue, and you'll force this thing into a full mode. So now you can perform charging diagnosis. It's easy to mess that up. You've got to be off idle. Any questions about that? That's kind of the neat thing about Hyundai is its ability to do that. Okay, so diagnosis for a Hyundai is the same, right? Sweep through those. Preliminary inspections, check the battery, check the belt, all those kind of things. The codes it sets, it's the same thing except it expands to kind of three that are common. The 620 for the control circuit, the 625 and 626, which are both FR circuit codes, just one's high, one's low. That's where with the other manufacturers there was really just two codes, one for input, one for output. Hyundai expanded the output side into two different ones. the values you receive, and we'll go through several of these because they get inverted. This vehicle is a Sonata, which is actually the vehicle I have out in the shop out there for us to look at today. The COM circuit, so key on, engine off, we got the command to start working. We started it up, value came down a little bit, but ideally we're going to compare these two. The values go up as you add load. The duty cycle command came up as I added more load to the car. The FR circuit, the feedback for the Sonata is the same way. Low load, high load. So it really kind of works the same as they all did, right? So if you talk to technicians, they pull up a scan tool and they set a code for FR circuit, or it doesn't matter which one it is, and they think it's this big complicated process of diagnosis, and it's really not. Back probe the wire, see if the value changes when you add load to it. If it does, then it's working. If it doesn't, it's not working, right? If it remains low all the time, it's open or shorted to ground, or if it remains high all the time, it's shorted to power. The Santa Fe is the inverted version, so that we have checked. So Santa Fe COM circuit, you can see low load was at 24. As I added load, the value went down. So the little handout sheets I gave you, I kind of put that on there this way. Those are kind of cheat sheets to throw in a toolbox. I put on there, if you back probe that wire and you see it at a given value, low load, you add load, it goes up or down. Do I care if it went up or down? No, I really don't. It changed. I know the PCM made a new command, right? Or if it's FR, I know the feedback changed. So that's really all that matters. So I try to take that confusion out of a Sonata is this and a Santa Fe is this and an Elantra is this, and just by saying, hey, if it goes up or down, as long as they work together, we're happy, it's working, it's doing its job. Okay, so as with all of them, this voltage drop business matters to us. It's the big deal. The older the car is, the more this matters. You know, with a brand new car, this isn't that big a deal. Over time, it certainly gets worse and worse and worse. Amperage always comes as the last thing on there. You got to verify, especially with this car, because you get into that mode where it's coming from two directions, and you can see 12 volts and high amperage. And what is that all about, right? It's part of that shared system. And then finally, there's the takeaway sheets that I gave you guys. Just kind of an overview of kind of covers each one of those books, kind of brings it into a one-page document.